So this year we all know that we've had a late spring and that planting season has been delayed, and it's been quite regional across the state of Minnesota. There's parts of the state, particularly southwest Minnesota and really along the I-90 corridor and south towards the Iowa border, where things have gotten really delayed. If we got the nitrogen on in the fall, we need to be thinking about the loss processes. We talked a lot about those in a lot of the information that we've put out this spring. First of all is the process of conversion from ammonia to nitrate. That process is microbial and therefore it's heat driven, so we didn't really expect a lot of that to have happened early on account of how cold things were. That only really picked up about the time we started to plant, so that was the first part of things. The second part, of course, is the actual loss processes are primarily water driven, and so we have had a significant amount of that. The question starts to become, did we lose a lot of the nitrogen that we put on? And in the case of a lot of the state, where while it's been challenging, it's not been impossible, it's not likely that we did lose a lot of nitrogen. It's likely that that we may have positionally moved some of that, but in addition, we know that a lot of the nitrogen also went on in the springtime, and that couldn't even get on until it got towards planting season. The southern part of the state, the extreme southern part and the southwestern part of the state, we're kind of in a situation now where we do need to start thinking about whether we've lost a significant amount of nitrogen now on account of the fact that it has gotten warm and it's continuing to be wet and the season is moving along. I guess part of that is going to be to assess what you put on for nitrogen and when you put it on. The fall applied nitrogen in particular is going to be at risk at this point, and obviously if you applied it in the springtime, not so much, and that would be with the exception of soils that are saturated. So we see denitrification happen in soils when they're saturated. That's the process by which the nitrates convert back into N2 gas and go off into the atmosphere. And so when we see soils saturated for extended periods of time, it starts at about 24 hours, and it's really kind of heat controlled also. The rate at which it happens is heat controlled because it is a microbial process. So the later we get in the spring and the warmer the soils get, we're going to be at greater and greater risk. We will see that, for instance, when the soils get as warm as 75 to 80 degrees, we can lose almost half of our nitrogen if the soils stay saturated for 10 days. That's an extreme condition in terms of being saturated for that long and being that warm. But we're within sight of June now, and so we'll have to start thinking about that. So even if you did get planted in that part of the state, you do want to keep an eye on your nitrogen. We have our nitrogen assessment tool worksheet that we can use that can kind of work you through the thought process. That's available on the Nutrient Management website. In addition to that, you could be using some of the newer technologies. Some of the computer models are capable of giving you a status of nitrogen also. We don't have complete research on those products to bless them in their entirety, but some of the early research we've done indicate that they do work fairly well, so that would be another decision aid that you can use. I'd really worry about getting planted, and that's probably the first thing. Second of all is the thought of using inhibitors. You will want to use a urease inhibitor if you're top dressing and just laying it on the surface. The urease inhibitors prevent the urea from volatilizing and blowing off into the air. Don't confuse them with the nitrification inhibitors like Instinct or N-Serve. Those products are intended to slow down the conversion of ammonium to nitrate. That's really not a process that you should be concerned about this late in the growing season. That's really to avoid risk of loss during the off season when we have a lag time between the amount of time we apply the nitrogen and when the plant starts taking it up. So fall, early spring are really the drivers for that. Obviously, it's not an environmental risk if you use those products, but it is kind of a risk as far as whether it actually pays for itself. Probably the only exception to that might be on sandy soils. That one, there is still a chance that there could be some benefit to using a nitrification inhibitor on sandy soils, but remember that our recommendations are that you're better off to split your nitrogen multiple times than to try and put it all on at once and hold it in place. And so if you have the ability to do multiple splits on sandy soils, I'd really focus on that more than using a nitrification inhibitor at this point.